Good morning. We want to answer this paper, Physics IGCSE, Year 65, October, November 2024, paper 20. This is multiple choice. First question, a student uses a meter to measure the length of a sheet of a paper. Which measurement is shown to the nearest millimeter? Nearest millimeter means 0, 0 is the nearest millimeter. And third decimal. A rock travels with an average speed of 6 meters for 2 minutes. What the distance traveled by the rocket? We know that the speed B equal the distance over time, so this distance equal B times T. So distance equals speed 6 times time 2. It is 6 kilometer per second, but this is minutes, so we need to convert minute to second. Times 60 gives you 720 kilometers. Diagram shows the vertical forces acting on the ball as it falls vertically through the air. The ball does not reach terminal velocity. You have two forces, weight and air resistance. They are not equal, so you have a resultant force, which describes what happened to the resultant force on the ball and what happened to the acceleration of free fall. For the resultant force, here, air resistance increases by the time because the speed increases until it becomes equal to the weight. So resultant force decreases by time. This is the weight. It's larger than the resistance, so we have the resultant force like this. But air resistance increases, so this resultant force decreases by time. Resultant force F R equal Fg, the weight, minus F drag, air resistance. The drag force increases by time, so the force of the resultant force decreases by time. As a resultant force, the force decreases by time, so the acceleration also decreases, which is logic because the acceleration decreases, it becomes zero, then you're going to reach the terminal velocity. So the answer is A. A coconut falls off a palm tree. At X, it has just started falling. Y the point before it hits the ground. What is the acceleration at the coconut at X? Air resistance can be ignored. What is the relation between acceleration here and acceleration here? Acceleration here at start falls, so acceleration of free fall. And here is before reaching the ground, so acceleration here E is the acceleration of, so the acceleration here and here is the same. So here is acceleration at X equal acceleration at Y. A car is driven around a bend in the road at a constant speed. What is the direction of the resultant force on the car when it's going round the bend? Direction of the resultant force as it going round the bend. Direction of the force is perpendicular to the direction of the car towards the center. The force is always directed to the center. Always directed to the center. The force and acceleration always towards the center. So it is perpendicular to the motion and toward the same side of the bend. Again, the force is perpendicular. Diagram shows a drop pitch is attached to a wall by a hinge at one end and cable and cabinet at the other. The weight of the drawbridge and the tension in the cable is represented by labeled arrows in the diagram. There is a third force at the hinge which is not shown, the drawbridge in the equilibrium. Which row shows possible direction for the force at the hinge? We have this rod, we have a force here, the weight, and another force here, the force of tension. The force of weight is directed downward and the force of tension directed upwards, supposed to be which row shows the possible direction of the force at the hinge. At the hinge here, the hinge of the wall is applying a force. This force is the direction, opposite of the direction of the tension. So it would be in this direction with the same angle here. Okay, so the answer is D. Which equation gives the momentum change of an object? Equation gives the momentum change of an object. We know that force is the rate of change in momentum. So change in momentum equals force delta t, which is also equals the impulse. Okay, so momentum change is a force distance of time, force times time. Force times time. Which statement about the use of nuclear fuel as an energy resource is correct? It obtained the energy from the sun. No, it has no environmental impact. Yes, it has. Nuclear power stations do not need turbines. No, of course, it does need turbines to generate electricity. The energy is released by nuclear fission. Yes, this is correct. The answer is D. Then question 9, the diagram shows an object of mass m being projected with speed v from point P to point Q on the top of the cliff of height h. The object does work against air resistance as it travels from B to Q. What is the kinetic energy of the object at reaches point Q? Okay, from P to the top of the cliff. At point P, kinetic energy here going to change into gravitational potential energy and work. This will happen at the top of the cliff. As objects start to falls down, okay, so gravitational potential energy and work gained against work done will change into kinetic energy. So at point P, so this is minus kinetic energy at, so we need kinetic energy at Q equal kinetic energy at P minus GB gravitational potential energy minus work. It equal kinetic energy at B equal half mass m b minus gravitational potential energy mg h and the work done. So it equals D. So the answer is D. A diagram shows a Sankey diagram for an electric drill. Energy input is here, and kinetic energy, which is needed from a drill, is here. There is thermal energy and sound. This is waste energy. Okay, scale distance between two lines is 40 joules. So distance here from this line to this line is 40 joules. What is the total waste shown by the diagram? What is the total wasted energy shown by the diagram? Okay, scale distance between two lines is 40 joule. Let's see, this waste energy here is the thermal energy and the sound energy. This is the useful energy, kinetic energy. We are talking about electric drain. We need electric energy, kinetic energy flow. So thermal energy and sound energy are not required. So these are the wasted energy. Let's see for the thermal energy, how many lines we have? 1, 2, 3, 4. 4 lines for the thermal energy. For the sound, it's just one line. Means 5 lines total for the waste energy. Each line equals 40 joule, which is equal to 100 joule. Okay.